I think we're going to start. Um, Today, we want to talk about software architecture, and we want to combine this with configuration management. But before we do our deep dive into the topic, I guess we better start with introducing ourselves. So, I'd like to start. My name is Ole Michaelis. We're both from Hamburg. You can find me on Twitter at CodeStars. My blog is codestars.eu, and this is Sönke.
Yeah, hi. I also work in Hamburg, and yeah, there's my Twitter handle and blog and GitHub as well.
All right. So we both work for a company called Jimdo. Jimdo is a do-it-yourself website creator. It's around till 7 years almost. So it's kind of a grown software, grown architecture. And our target is that everyone can create websites easily. But that's not the topic of today's talk. So, topic of today's talk and the goal of this presentation is Sönke and I, we're both not real system administrators or ops guys. We're really software engineers. So, but somehow it forced us to do some ops in our company. So what we did is we applied all the software architecture patterns we know to the configuration management we do. So it's really about software patterns, which also applies to infrastructure management code. We'll show you some anti-patterns, like how not to do it, but we'll also show you the other side, like the best practices and how we do it, and the way we found that's really a good way to do it because it's maintainable and stuff. We should mention that this talk is somehow bound to Puppet, because we do Puppet in our company, and all the examples are in Puppet. But hopefully all the best practices are applicable to Chef and other configuration management tools too. So we'd like to start with a little poll. And the first question, which is really obvious, is who patched their SSL yesterday? Okay, I assume the rest is like us. Your operation system is that old that you don't have to patch it. Okay, so who's the sysadmin? Oh, that's almost... We did this talk at a development conference, and there was just one ops guy. He seemed really lost. So who's a developer? Two. Okay, that's really funny. It's the other way around. So who used configuration management at all? That's almost everyone. That's great. So who do Puppet? That's great. Who do Chef?
Oh.
Two?
Good audience for us.
It's okay. Okay, I assume the rest do Ansible and other weird stuff. No, there was not biased at all. Okay, who knew these pictures? Who've seen them? One.
Oh, one, yeah.
Okay, that's cool because this is our topic today. These are some pictures I stole from this motivational posters about Solid. Solid is a software principle which are 5 abbreviations for patterns. And the first one, the S, is the single responsibility principle. It's that a class should only have one single responsibility. And the O is the open-close principle. It says that software entities should be open for extension, but closed for modification. The L stands for the Liskov substitution principle. And that's being said that objects in a program should be replaced with instances of their subtypes without altering the correctness of the program. It's kind of related to design by contract. Don't worry if it's really weird stuff I'm talking about. This is the topic of today, so we have almost 1 hour left to dig into detail what this really means. The I is the interface recognition principle. It means many client-specific interfaces are better than one general-purpose interface. And the D is the dependency inversion principle. So one should only depend upon abstractions and do not depend upon concretions. Dependency injection, you might hear of it, is one implementation or one method following this principle. And, to do this more we want to present this in a more lively way. So we prepared a little role play.
Yeah.
All right, as you see, I'm the typical ops guy. I wear black shirts, long hair. I also had a hairband, but I will fix my lovely hair later on. All right, so let's start. Sönke, hey,
Yeah,
how you
hi.
doing?
How are you?
I've been to many conferences in the last days, and I heard so much stuff about configuration management, and I'm wondering what is it all about? So what is it?
Yeah. And why? So because usually it's like you just have your bash scripts and you actually like it, maybe.
I love my bash script. They're
Yeah.
awesome. They're all
Okay.
on one NFS server, and you know this service. It's everywhere, and it's super easy to manage for me.
Yeah, that's cool. Okay, so let's go a little bit into detail. So what the heck is configuration management? Configuration management has some more definitions, but this is one definition, and it's like declared by 4 words. And the first is it's idempotent, or idempotent, I don't know how it is in English. So who of you has already heard of idempotency, this pattern, or, okay? Bunch of people. So actually idempotence means that the current state of the system doesn't matter. You can just think of, for example, HTTP verbs, like when you do a get or you do a delete on some HTTP object on your server, it should be idempotent. So you can do it, you can just repeat it, and the state on the server doesn't get really changed. It's got changed. So if you delete an item once, then it's okay. If you say twice delete it, then it's not deleted anymore, but the server still says it's okay. So this is idempotent. And the second thing is like declarative. So it's like SQL. Like you don't say how things are going to be done. You just say what to do. And so SQL, Chef, and Puppet, for example, are declarative. It's not like Bash where you tell like copy stuff there and move and unzip and tar and stuff like that. Yes. So and the third thing is convergent. So you just in configuration management, this is somehow a little bit like declarative. You say what should be done, but not how, and the configuration management just takes care of what to do. So it's also re-entrant. So if it broke, if the last run broke, then it's just the rest is getting applied, and not like your bash script, which might just fail in the middle, and then you have some undesired state of your system, and it's just like, oh my god, I don't know what to do. And yeah, and the last thing is abstract. And it means that, for example, package management is abstracted for you, so you don't have to care about is it apt or yum or whatever.
All right, that sounds really cool.
Yeah.
But you know, why is it better than my Bash and SSH stuff? You know, why should I use it?
Yeah, I would say you could look maybe at this photos. So what is software architecture about? You can see what good architecture is. It's like 2,000 years, the aqueduct in Rome, and versus this bridge. And so with good software architecture, you get some overall structure of your system. You can see where the boundaries are. You can interchange single components. You don't have this spaghetti code and dependencies everywhere. And you also have standards which other people can rely on and stuff like that. And you can scale your company much better because usually there's this one admin guy and he has all the special knowledge about his or her bash scripts, and this is not good for scaling companies. So it's good to have some standards how to do it. Yeah.
That sounds really good. So I think I want to try it. I think I want to go with Puppet, because you know you're talking about Puppet all the time, and I heard it's like the best config management in the world. So I was like back in the days like last week. I did my first Puppet recipe. So check out my first Puppet recipe. It's really cool. So I have 3 web apps running on 3 nodes. So the first is like web app 1. It needs an Apache, and there's web app 2. It has fast CGI, and then web app 3 is like our legacy system, and it has like both. So it has and it has some special modules in the PHP ini. So how do you think? I mean, I really like it. It's way better than the best stuff. So what do you think?
So it's really cool for a start. So actually what you did is like you wrote your first PHP class and you're just installing packages, and you have this like special file here. But so from a software engineering point of view, there are several mistakes in that which could be improved. So the first thing is global state. We have a global variable here, and so the problem of global variables is always that you don't have, for example, reusability anymore or testability, and you have like pollution of global namespaces. Just imagine there is another class which also has fast CGI, and they are like battling who's the winner of has fast CGI. So and the next one is actually our PHP 5 model has to know something about roles. So you introduce some kind of role model here, like this is my web app C role, and this is also not good because it's just not in this context. This module should not know about other stuff around or higher layers. And the last one is we will get to this later. It's like the file server here. You just use your Puppet as a file server for your stuff, but we will get to this later. So this one. So how can we get rid of the global state? What we can do is we can just let's see this example again. So we have like, we have this global state, like this has fast CGI variable and this role variable, and that's not good. So how can we make it better? We can get rid of the global scope, and how do we do it? We just pass into the class the stuff we want to know, instead of calling it from the inside. And this is really cool because now this PHP 5 class is kind of self-contained, has no side effects anymore because it doesn't talk to the global state or other outside components or modules, and it does not pollute the global namespace, like what I said before. And the cool thing about it, it's reusable in other environments. So you could, for example, open source it.
That's really cool.
Yeah, that's really cool. And on the calling side, it looks like this. You just pass in the variables instead of calling it from the outside. So now your 2 nodes, like web 1 and web 2, they include the PHP 5 class still, but they have these injections here. And that's cool because now we could also get rid of these variables and just pass it in here. So again, no global state, and also no global variables like role and has fast CGI or whatever role variables that are not needed anymore anywhere. Okay, and this is actually called dependency injection, and this is our first pattern of Solid. It's the D in Solid. And this is, it's like called dependency inversion or dependency injection. There are many words for it and names. And this is really cool. And I would say, now we got our first.
That's amazing.
Mission accomplished.
High five. Okay, nice. I think I get it now. This default dependency inversion is pretty important to me because I really learned that global state is bad. So whenever I see like some of my colleagues doing this global state stuff, I will totally go ahead and say no, don't do it. Use dependency inversion because it's way better. We don't have any side effects. It's reusable. Sorry, and we can also inject parameters. So it's way easier to maintain, and I totally love that fact. So that's really great. But
there's still many things to do. For example, we still have all this ifs in here, like if has fastCGI, if has Apache, but
you know it's not that bad. I feel like it's well arranged and it's super easy for me to change that later on because it's really like overviewable and it's not that much.
And you could just add more ifs.
I would just add some more when I have like another special cases.
Yeah. That's okay, but in the end, trust me, I'm a developer, and so actually you will end up with stuff like this. And so actually, this is one live example from our Puppet code base. So we also started with some technical depth. And so this is really an example from a grown code base. And the problem here is if you want to change anything and you want to make sure that you don't break anything, then you're really lost. And actually, there's an anti-pattern word for it. It's from the C2 wiki, and it's called the arrow anti-pattern because your code somehow looks like an arrow. So there's also a name for it. And actually, when you're trying to do some refactoring or try to change it, then you will end up like this cat. You maybe know this cat. Who knows this cat? Yeah, really poor cat. Okay.
So I think I get it. So can we split the PHP 5 class into smaller pieces without breaking stuff? So how can we accomplish it? I mean, you said you won't break stuff, but I don't want to break stuff. But show me. I don't know how to do it.
Yeah. So actually, what we do in software engineering is like test all the things. Because then we can make sure we don't break anything, and we can also make sure that we always have some working code. And so luckily in the configuration management world, there's a lot of tools that help us. So we could start like with RSpec Puppet or test in the Puppet world and Test Kitchen in the Chef world, for example. And what is now cool, because we have a testing tool, we get another pattern from software engineering, and it's called test-driven development. Who knows this cycle, like red-green refactor? Okay, a bunch of people. So the cool thing here is that our infrastructure or our server definitions or node definitions are now code. We really can express it with code. And in software development, what we can do in software development is we can do test-driven programming. And now we can apply this and can do test-driven infrastructure. And we can use this cycle. And the cycle says, write a failing test, like you don't implement anything. Then write anything to make this test green, maybe also with copy and paste, it doesn't matter. And then do refactor, because then you can just like get rid of copy and paste and stuff like that, because you have your tests and you make sure that you never will implement one line without a test. And this is really cool. And there's also another important thing about test-driven development. If something is not testable, then your stuff might be wrong, your design might be wrong, because good software is usually testable. Last point of all the advantages test-driven development gives you is you have to think before you implement. And this is really important because there are several cases when you have to think, what should my software do? Then you have to think beforehand, and sometimes it's like, oh my God, no, I don't want to do this, and then you get, then you will just try to implement it in another way or get rid of the feature because you just thought, oh my God, this won't work. I better let it be. Yeah. So, okay, how can we get into test-driven development with our small example? What we could do is, the first step is we have to document the current state, what our stuff does. And actually we have our 2 nodes, or 3 nodes, sorry, and we can just add these really simple tests like my node web1 should contain the package PHP fastCGI. This is actually what is expressed in the manifest of Puppet, and so on, like with web 2 and web 3. And this is called integration testing because we now test that a node actually contains a package, but there should be one layer in between those both, and we will get to this now. And the special WebAppC stuff is now left out. We will get back to this later. Okay, so now how is TDD going to work? What you could do now is you could you have these tests like on the slide before, and now you can just go ahead and write some new classes like PHP fastCGI and PHP Apache, and you will just test that it's going to be installed. Now we have 2 small classes. They do one thing, and this is really cool because this is the next pattern. It's called single responsibility. It's one piece of software, a component or a class or a container does just one single thing with one responsibility. And this is, and what we can do now, yeah, so we had this, so we came from this like web1 should contain PHP fastCGI, but now we have this both new classes like PHP 5 Apache and PHP 5 fastCGI, sorry. And now our tests look like, okay, it should do both. It should contain include the class, and it should also contain the package. And this is now redundant because actually we now can get rid of those tests, because those tests like the PHP 5 Apache class, they have their own tests. Like I should include the package, so I don't need to do it anymore in my node definition tests. Yeah, and this is really cool because now we have like clear layering, and because we now test that our node includes some modules, and we like the small classes, and the classes have their own tests. And we can now compose it together like we want, and this is cool. And actually, it's like this. We come from spaghetti code to lasagna code, like clearly layered code. So you may know this from Java, from the big stack trace. This is actually lasagna code. It also has its disadvantages, but usually it's better than spaghetti code. Yeah. And actually, this is the next pattern. It's the open-close principle. That means that our software or our small class or component should be open for extension. And the really important point here is that you don't add new functionality by, for example, adding new ifs, but you do it by adding new classes and compose stuff together. And this is like what this little text here says, like rather than by changing existing code. And this is really important, and this is one really important pattern to have maintainable software, or in this case, configuration management. because you won't get these big like God classes which do everything. Yeah, and actually,
it's high five time.
yeah, bam,
Woo!
because we
okay, this is really cool. I really like that fact, and I think I almost get that. So when I want to add a feature, and I find myself like modifying actual existing code, it's already what we call a code smell. Like you said,
Yes.
you would call it code smell, because you should realize that new stuff is always like new features is always like a new class, and when I want to add a feature, it's again like writing code. And when I use tests and the refactoring cycle you showed me, I can really ensure that I won't break existing functionality, which is really, really cool again.
Yeah. So, and you realize it before your customers do, because there is
This
no
this one is called customer testing, right?
Yes. It's test units, not unit tests. Yeah.
Okay. I think when I want to scale these things, it's like when I want to scale now, what I would do, because we just made it so easy, really, I would just go ahead and like copy the node definition and change the things I want to.
So.
I want to do.
So, for example,
this is really cool.
So, for example, when you get more load, and now you can just add another node, because
This I would totally do that.
Yeah.
So when we have this success disaster that I need more nodes, I would just go ahead in my manifest and add these nodes. Like
yeah. So actually, this is the old copy and paste anti-pattern. So yeah, and copy and paste is really easy to do. And this is why it's so popular. But it's getting evil, because imagine you got hundreds of nodes. Then you have this node definition 100 times, and you got the content copy and pasted 100 times. And now imagine you have to change one thing. You have to change it 100 times, or someone else has to make the change, but he doesn't know, or she doesn't know about the other 100 occurrences, and then you're getting lost.
Okay. So you said that just better don't copy, but the actual question is like, how can I achieve it then when I don't do this copy and paste stuff?
Yeah. So what you actually could do is like you add another layer into your lasagna code. For example, what you could do is using composition, you could say, my web app 1 is some kind of a server role, because web app 1 and 1a, or how we call it, it's just the same, and it's somehow expressed in a server role. Like a role says it does specific things, and so what we could do is just add this layer, like a role class, and it says it's a web app A, so it has actually a name, what it's doing, and it just says include the Apache module. And now our nodes are just including this role, so another layer, like I said. And this is actually called composition, and composition is always better than copy and paste, because now you can just add more stuff into your role, like it also has to include whatever, and you don't have to do any copy and paste. And this is really cool, because yeah, now you got rid of this copy and paste stuff, and it's clean again.
All right, high five time.
Bam.
Cool. So I think I got it. So this role concept is like really easy, because I can compose stuff. I have again reusable code, which is like the one principle of software design, I guess. And nodes are just described by a role, so the node should only contain one role, which is really handy when I want to scale. And then I have little changes. I don't have to do it for every node, because they all include this one role, so I can make this actual change in the role. And this composition stuff makes it really easy to add new nodes.
Yeah, you got it.
This
cool.
is super amazing. So I really like that. So okay, I got rid of the global state. We have small classes and we got tests. But why has this PHP 5 to know about our role model? Isn't this like breaking the proper layering you just mentioned?
Yes, I mentioned it a few minutes ago, like it still has to know about the role model, and so we have to look what can we do about this, because actually if we want to have this fast CGI class somehow interchangeable, or then it doesn't just must not know about our role model, because the role model is what we did, and the PHP 5 class should live without any knowledge of it. Yeah, and actually, again, we have some principle. It's called the Hollywood principle. It's the same as the dependency inversion principle, but it's a little bit funnier, because like in Hollywood, it's always like, don't call us, we call you. So actors usually get called by the agency, and so the agency can just keep their options open, and this is really important. Yeah, as I said, it's just another name for the dependency inversion. So what we could do now is, like, we had this special case, and how to get rid of the special case, we could just add another, or extract the code with the special case out and move it into some special class. I called it like role webappc special PHP stuff, and now it's in its own class. And what we could do now is inject this package, or this special class, into our fast CGI class, and give it some name that actually expresses what it's doing. Like, it should include this class, or it should include like this stuff after the package install of the PHP 5. This is like what we do here, like with this package PHP 5 and this arrow like class. This is like the Puppet syntax for it, or one way to do it. And now, this is really cool, because now we have some kind of a pluggable system. We can just plug in this class, and now it's reusable. It doesn't need to know anything about the role model, and we can reuse this hook. So in software engineering, we also say it's like a hook, where you can hook in stuff, and it's just getting called. So it's this don't call us, we call you, because now the special code does not do anything with the outside. It's like the actual class fastCGI is calling with the include. It's calling the special class with this include. And that's really cool, because it's now it's reusable. And yeah, and as I said, like, this is how it's called. It's like include after package install, and we just say include this special profile. And now it's a dependency, and it's clear that it's a dependency, but it's injected. So as I said, like, the PHP fast CGI class doesn't have to know anything about the implementation of this special stuff. It just executes it. Yeah, and this is, as I said, the Hollywood principle.
High five time!
Yeah.
Okay, so I think I got that point too. So now we got a clear PHP 5 FCGI class, and we got this clean hooks principle. So whenever I have some like indirections in my code, and someone is like executing code it's just not belonging to, I can implement this kind of a hook system.
Yes.
So the other side can always just inject the piece of code which should be executed when the hook is like triggered. So this is really, really cool. Okay, now we still got this special PHP config.
Oh yeah.
For this webappc, which is just it's just a file, you know.
Yeah, it's just a file. The problem here is it's just a file is a real big anti-pattern of configuration management, because earlier we said that configuration management should be declarative and abstract, and what we do now here is just push some, like in your bash script, you just push some file to somewhere, and this is a problem because it just encourages, again, copy and paste. Like, imagine you have now a special PHP ini for web app A, and then you will just go ahead and copy the special PHP from web app C and just change some stuff. Yeah.
Okay. So, but tell me, how can I fix that?
Yeah. So actually, what we can do is we again express stuff declarative. What we could do is like we could say, hey, what does this express? It's like a special config for PHP and for our PHP install. So why not express it in our code that it's actually a special config, so anyone who reads this code just knows, okay, it's a special config. And you just pass in, like we learned, like you pass in all the dependencies, like ensure present, like it should be present by default, and then you can say, and you can also inject the path, and it has a same default. And what you can do now then is like you could use a module for composing ini files. So again, your ini file, you don't just have this file, you just go ahead and just say, okay, it's an ini setting and it has a title and it has a section and a key and a value. And the cool thing about it is you can test it again with your aspect puppet. You could just say like contain, should contain PHP special config, or you could test should contain some ini setting and stuff like that. And this is really cool because the other way to do it would be like testing it with regular expressions or really evil stuff.
This.
Yeah. Yeah, and this is really cool. And now this is again, this declarative stuff. So describe what should be done, not how it should be done. How it should be done should always be like hidden. For example, in this ini setting module, which someone wrote somewhere and you just download in your library folder.
And they hopefully tested it,
yeah,
right?
and hopefully they tested it and it works. If you find a bug, you can just go to GitHub, open pull request, fix it. Yeah, it's like in software engineering. Yeah.
All right, high five time again. So we finally got rid of my file server. Frankly, I had a intimate relation with them, and it was really cool. But somehow, on the other hand, it was really great that we removed it, because we get all the advantages we had now with the declarative programming, the idempotent stuff. This is really cool, and this makes my daily work. And it's just way easier now because I just have to say what should be done and not how. And I don't want to have my notes in Puppet, because all the stuff you mentioned. What happens if I have to scale really hard? Imagine our marketing department does some awesome advertisement on TV, and I expect the hundreds amount of users I'm getting now, and I have to put all these notes I want to add in the manifest again. So I have to add every node and so many lines of code. Can we just fix it?
I guess we can. Let's just do some Google search and let's see how we can actually. So what we have to do is we have to separate code and data. So our code says, hey, include this class, blah blah blah. But the data actually is we have thousands of nodes, and this thousand nodes should get this this role model and stuff like that. So. In the Puppet world, we actually, when we search for separating data and code, we will find Hira, and Hira is a tool to get rid of all the data in your Puppet manifest and just push it. For example, this is really an example to YAML. So what we could do here is we could say the web1 YAML, and we could also say it should include the profile web app A. And so on. So we can just express how a node looks, and we can do it, for example, in YAML. But and actually, our node definition now would be not like this, repeating it all the time. We could just do Hira include, and this Hira include would just look up what to do.
Okay. So I get this. I can just define it externally and not in my Puppet, but. YAML is still static, so why is the difference if I just enter my notes in the manifest and or in a YAML file?
Yeah, that's still a problem because now we moved it we moved the data out to another layer, but it's still there and it's still somehow copy and paste.
But I would bet you have a solution for that too.
Yeah, of course I have a solution for this because I'm Dr. Software. So actually, the cool thing about Hira is it's pluggable, and you can just do whatever you want. You can implement your own backend, and you can use like getting stuff from DNS or from your existing LDAP stuff, or you can just write your own backend because you already have your like configuration management database, and it contains all the nodes and maybe also the roles. Then you could just write a really thin layer to express how a node should look like. And you could also do it like with connected to some APIs like an AWS or with CloudFormation or stuff like that. Actually, we did it at Jimdo. We have some plugin like Hyra AWS, and it just gets information out of AWS, so we don't have to copy and paste it into Puppet. Yeah, and this is really cool because now actually we get a configuration management for our configuration management. Yeah, like Exhibit always tells us. And
high five time!
Again.
All right, so I got it, and it's really cool that I can manage my data center without any monkey task at all. It's just like when I plug in the node and I boot it, and the rest just happen automatically. The node, is registering itself at our AWS, for example, or LDAP or whatever, and then Puppet can provision itself because we have this Hyra backend. So it's really cool by just discovering nodes with Hyra. And this is the real way of configuration management, and I'm so thankful that you showed me like how to do it and how to get rid of my NFS stuff. Okay, so the role play is kind of over. Don't hate me for my bad hair now. It was really warm under there. Okay, so let's make a resume. We have Solid in software world for like a couple of years now already, and we always mentioned it's not a Jenga game like it was mentioned in the beginning because it's very fragile and you can break stuff really easy. It's more like Lego, you have small parts, little modules, you can compose them whatever way you like, and you can create new stuff with existing modules. We often call this Lego programming because it's really like that. You don't program new modules, you're more like configuring stuff. You're putting existing systems together to create something new. And I can always encourage you to learn from software development world, because all the configuration management stuff takes has so many similarities to software development, and it would be like a shame if we don't apply the stuff the software world already uses for so many years and don't apply it to configuration management. I mean, this is what we see in Puppet world nowadays. Like, they're making the exact same mistakes as PHP. We just discussed it yesterday, right?
Yeah.
And this is so bad, and this really hurts me because I have seen PHP gone through all this shit, and it's really hard to see that they do exactly the same mistakes because they don't look at the software world, which is really bad. And I guess Sönke has to tell us something about the I and the L, because this one is still missing.
Yeah, it's still missing, and yeah. So actually, we had we don't have this interface segregation, and the problem here is that interface segregation doesn't really apply to Puppet because you don't have stuff like interfaces. In the software world, you have stuff like interfaces, and it should use small interfaces. It could apply somehow, like when your class or your define looks like, oh, there are 20 params passed, then it's like a code smell, and you might look into how to break it into smaller classes or pieces. Yeah.
But we were really curious. So if you know like a pattern or like a way of configuration management which is similar to interface segregation, we would love to discuss that with you afterwards.
Yeah.
Because we were really our goal for this talk was to apply all the software principles, like all the Solid principles. But for the I, it was really hard to find something.
Yeah, and it was even harder for the L a little bit, because the L is about how inheritance works, and actually, at least in Puppet, it's like you can do inheritance, but they all say don't do it because
it's not there, right?
Yeah, because actually you should always use composition and not inheritance. So just plug your plug your defines and classes together and don't do any inheritance. Yeah. Yeah, so what we got is like SOT. No problem. Yeah.
No? Okay, yeah, so we got SOT, it's not solid, but maybe we can implement like this SOT. So as we have solid in software world, you can go back to your company and say, all right, I learned about SOT, and all your colleagues will question like, hey, what's SOT? Never heard it. And then you can go ahead and explain that because it makes like configuration management code just more solid. On the last part of the slide, we want to share some best practices we gathered, like real best practices, not this manly best practices, like real best practices, which don't kill you. The first one is like what we had a slice of that in the role play. It's like the role model we got. So you have nodes in Puppet, and for us, every node has one single role. It has not more roles, it's just really bound to one role. And this role consists of several profiles. And the profile then has more modules, and they reuse resources. And talking about open source here, everything behind these modules should be open sourceable within a day.
Yeah.
And that day should be spent in writing documentation.
This is the rule of thumb is like all your models should be open sourceable, and they should not like call stuff from modules or role or global namespace.
I mean, we know we're talking about a world which is like, we are talking about the perfect world with, you know, candy and rainbows and unicorns. We don't have that too. Not all our modules are open source. But whenever we write new stuff, we have this rule in mind, and we try to program it like that we could open source it like any day.
Yeah, so actually, we talked about like this open source, like in the Puppet community, you have the Puppet Forge. It's like Ruby gems, or in the Ruby world, or whatever, or CPAN in the Perl world, and it's just a Puppet module registry. So before you're going to implement stuff on your own, better look there, because you might save some time.
Yeah, there's also a pre-built PHP 5 module, but I wouldn't have learned so much if we would just have used it, right?
Yeah, actually we could have just used the PHP 5 module, but it would not have that learning effect for you.
And the next one is the dependency management, like all the modules which are open sourceable, you have kind of to manage them, right? And if you do it, you can like use Git submodules, or all the way like of don't doing it. But what can happen pretty quickly is like that the city of Forks welcomes you, because you're doing little fixes and you have no way to contribute it back. You have no way to manage your submodules in a correct manner, and you would end up like chaos pretty quickly. So what we can really recommend is like using pre-built tools for that. For example, there's Librarian Puppet. There's how's it pronounced, like R10K?
R10K. Yeah.
It's like a best practices and code collection for Puppet modules. And talking about Chef, there's Bergshelf. And it's just little layers you can use in your like deployment process or in your Puppet master, which pulls down all the modules you specify in a dedicated file. If you do programming, you might know tools like Bundler, pip, easy install, and all the Python ones, or Peer, or Composer in PHP world.
Yeah, and so actually there's also, in the Puppet world, there's some guy, and he does like this standard mod, and it's a cool way to, it's like a standardization effort to how modules should look like. So if you're going to write your own module, just have a look there, how to do it and how to do all this stuff. Like it should be generic, and it should work maybe not only on your Ubuntu or Debian, but also on whatever, Fedora, or even Windows, but
let's give this for here. It's pretty similar to what you might know as PEP 8 or PSR, like all the programming tools they slowly come up with that too. Like they have pretty hard standards, and it makes the life of everyone easier if you just follow them. And if the majority of the community agrees on it, make your lives easier and just don't question it. But this is a really personal opinion. And this one we want to share from like our daily business we are doing. Jimlo has obviously a GitHub account, And you can find some really cool stuff on that, because what we do when we write a new module, we have kind of a sandbox or template. We just fork that repo, what you see there, the Puppet skeleton, and it contains a lot of pre-built stuff already. Like, for example, there's a README. It's almost completely written, because a lot of stuff is pretty similar to modules, to Puppet modules. You just have to like replace smaller parts, like how to use it, and not like writing, for example, a license all the time. There's a pre-built manifest file. There's all the folder structure. There's tests. It's a complete test setup. It's already done in this sandbox, in this skeleton. There's a Vagrant file, and we have server spec in there. Yeah. So you can really do test-driven development and set up a new module within, I don't know, 5 minutes, because we have done all the stuff, all the repeatable work. And our coworker who did it, Matthias Lafeld, he also did this for Chef. And this is really cool. It makes development way easier. And Sönke mentioned the AWS Hira backend, and you can also find that one in our GitHub account.
Yeah, so next one, like you just mentioned it, like there are also other tools to test your manifest, because what we did now is like with this RSpec stuff, we just test that it might apply, but actually we don't. It just compiles the Puppet catalog, but it doesn't test if it really works. And with the tools like server spec, it really just spins up a Vagrant box and just actually applies your manifest, and you can see it, and you can also combine it again with this RSpec, and then it's really like what we showed you, like with this, it should install blah blah blah, and then you can just get a real cool integration test if your module really works, and if it really works, for example, not only on your Ubuntu but also on a Fedora, because you can just implement more or plug in more Vagrant boxes and stuff like that. Yeah, and the other tool is relatively new. Also, so server spec is agnostic. It's for Chef, at least for Chef and Puppet. Beaker is Puppet specific, and it's really cool because you can also say, like, on the master, on the Puppet master, there should just happen this, and on the node there should happen this, and stuff like that. So it's a really cool integration tool. It's relatively new. Yeah.
All right. That's all we got. Thank you very much. And now we got like 7 minutes for questions, if you got some. And if you don't want to ask now, we are around for the next 2 days, and you can always find us around here and ask us stuff about like how we do it, or discuss stuff with us, because we talk completely bullshit. We also want to know that. So, questions?
Yeah. I have one about this test-driven development. You presented a slide with this
the
syntax there about that. You said this is the test, now this is the implementation. I wasn't quite familiar with this the syntax thing. It looks like Puppet, but where does it come from? Is it
so the question was what's the syntax? Yeah. So what's the syntax for the testing? It was RSpec. It's Ruby. So this describe and it should blah blah blah. This is actually Ruby code.
RSpec is just a testing framework for Ruby. Yeah.
So
this RSpec is a tool you can use, and you write a test.
Yeah.
And you can test it against Puppet.
Correct. It's RSpec Puppet. So there is RSpec, and there's one guy, and he wrote RSpec Puppet, which is just an extension for RSpec, and you can just test this catalog stuff with it. Yeah. More questions? Yeah.
Do you actually test your servers?
Sorry?
How do you actually test your servers?
So the question was, how do we actually test our servers? So actually, we don't. So we
that's
test.
so easy.
so what we do is we try to write tests for everything. So like with this RSpec Puppet, and if it's green, then it's okay for us. Then we just merge it, and Puppet runs every hour and just applies. And if it, so actually we never had a bad case like Puppet goes weird and maybe uninstalls itself or stuff like that. Or so yeah, so actually we never had problems, and we also have just like one branch, and we just work with pull requests. Like we open a pull request, then Travis is going, so the continuous integration is going to test, execute all the tests, and if it's green and somebody reviewed the code, then we can merge it, and then it goes live within the next hour. But I know that you could just, with continuous integration, you could do stuff like spin up a machine somewhere and apply the stuff and just look if the web server runs, and you could do some more smoke testing. Yeah.
I guess the actual question would be is it really necessary to test the service if you have like a completely covered Puppet or Chef file? I mean, testing always takes at least like development time, or like the time you have to write the tests. And if you do like real server testing, you need the server resources, you need a free server to do it, and like spinning up the machine, if you would do it like that, it would also take time, and it will slow down development because your feature will take more time to go out. And what I learned like in software development testing is like people tend to test all this stuff. Some people even test like getters and setters, so they test like, I set this variable, and then the next time they test if this variable set, which is kind of bullshit for me, because you should only test like business critical stuff. I know that in server world, a lot of stuff is business critical, when it's like all the stuff is business critical, but like you should only test like fragile parts, not this like, okay, I install a package, and if this package installed, might not be a test which is like really necessary on the real world. But yeah, maybe I'm wrong. So.
Yeah, I mean, like your Puppet receives deploy a server, but there's no guarantee that the Tomcat whatever would start up, that the application would work, that it would like its database, and so on.
Yeah. So actually, so the problem is like, how do you know that if you spin up a new machine, how do you know that all your services are up? So actually, we do it like, we have like automated monitoring for it, because the Puppet also sets up the monitoring, like is Tomcat running? And so because the node definition just includes also the monitoring, and the node then registers itself in the monitoring system, and then you can just see it in the monitoring if it's up. And so for us, that's really enough, because we can see it in the monitoring, and the monitoring is the single source of truth if stuff works or not. So yeah, we just do it with monitoring then.
I guess we have time for one last question, if there's one.
Do you use the Puppet client as a running process, or you invoke it hourly by something like that?
So the question was if we run Puppet as a daemon, the agent as a daemon. No, we don't. We run it hourly. There's a cool tool one of our coworkers wrote. It's called periodic noise. It's a small Go tool, and it's for all this stuff like I have cron jobs, and cron jobs tend to fail, and then someone gets a mail, and or not, or he's on vacation. And so what he did is like all the stuff what you need for periodic tasks, like doing like spreading it out for an interval. So for example, you don't want that all your Puppet agents start at 0, because then your master gets overloaded, so it just spreads it out over 20 minutes, and it actually, if it fails, then it will just, so we have also a Puppet module for it, like Puppet periodic noise, and we can just go into Puppet and say, we have a monitored cron, so we do a cron job, but it's monitored because periodic noise also integrates into the monitoring, and it just says like, oh my god, the Puppet run failed, and then it's getting red in our monitoring system. Or like it's getting red after 2 times because there could be some network glitch or whatever, and we just don't care about one failing run.
And the periodic noise also takes care of locking, like guarantee that the process is not run in parallel, and it also does logging.
Yeah, it does all the stuff you implement on your own all the time. So please use it.
Yeah, so it's and it's also up on GitHub. So just check it out. All right, I guess that's it. If you have any further questions, whatever, just come and find us. Thank you very much.
Thanks.